talking about the climate
I wonder
and
is it in miscellaneous or is it in? So excited.
What sort of climatological event is going on now that's going to be affecting our weather for the next day or so? Anybody know? Hello. Okay, well, we've had a couple of them. One last week, and we got another one going on now. I'm talking about what was Hurricane Maria, and now I guess it's technically Tropical Storm Maria, is out off of was just east of Cape Hatteras, and these tropical storms are a major contributory factor to our weather that we deal with. It's been severe enough that they have had an evacuation of folks off of Ocracoke and Cape Hatteras in the last 18 to 24 hours. There's about 10,000 people, visitors, that they've asked to leave those areas because of the wind and potential storm surge that is occurring, or potentially going to occur from this storm. So, this is not going to affect us greatly other than wind. I'm sure, Tom, you guys are going to get a little more wind than what we are here, and the folks down in Southwest won't even notice the breeze, I don't imagine, from it, because of the difference in the topography and the elevation that they are, and the mountain's going to buffer most of it off of them. But you guys are close enough to the coast that I imagine you'll be getting some 20 to 25 mile an hour winds probably later today and tonight from the storm. And this storm, the one we're currently enjoying or having, we not need to use enjoy, but it's been modified because of the last storm that we had. The last storm that went up the coast tended to, it was pretty violent, and it did a lot of stirring of the water, for lack of a better way of describing it. And these tropical storms feed on warm water, and the fact that this other storm was there and stirred up the water, it changed the temperature of the surface water. It brought it down several degrees, made it cooler, and that in effect has weakened the storm that we're currently dealing with. So a 10 or 12 degree reduction in that water temperature has caused this second storm, Maria, to weaken considerably. But these tropical storms are a component in what we call the hydrological cycle. And Tom says you've got access to the picture out of the textbook it's a graphic of the hydrological cycle, and it talks about or depicts a lot of the processes that are involved with the cycle that water takes in our atmosphere and soil, and it is a cycle. We get evaporation from bodies of water that increase the moisture level in the air, and that moisture level the air will rise, and when it does that, it cools and condenses, and then we'll begin to get precipitation. That precipitation falls to the ground and will either land in a stream or land on soil. If it goes in soil, it begins a process we call percolation, and it goes down to groundwater or an aquifer. And those aquifers will eventually come to the surface in terms of a some sort of groundwater, either a spring or a stream that feeds the rivers. The different streams that we have in our area. For example, we've got an area in the northern part of Patrick County, a little community called Meadows of Dan. And that is just a little village type thing, but it is named after the little land masses that are around the origins of the Dan River. And the Dan River originates there, and it flows down the mountain. Actually goes into North Carolina, and then it swings back into Virginia near Danville. And then it becomes a component of it joins with the Roanoke River or the Stanton River to fall, and then it's dammed up for the dam at Bugs Island. And then that water goes into the watershed that goes into the Albemarle Sound. So, that creates a cycle from rainwater falling to then the groundwater, and then the water going into those bodies of water. So, it is a cycle, and there's quite a bit of terminology that we'll talk about as we do that. But one of the things that's the climatologists are debating now is, in theory, our change in our climate. How many of you are a believer in what we call global warming? Any of you believe in the theory that we're experiencing global warming, or do you think it's just a normal cycle that occurs and it'll swing back?
Probably a normal cycle.
Try a little louder, I couldn't hear you.
Possibly a normal cycle.
Okay. Anybody else?
No, you said the opposite answer, so one else was right.
Okay. I'm like you. I think it is a part of a normal cyclic effect that has occurred in our world over an extended period of time. And I think these guys that are, and this is my personal opinion, but I think that they're looking at a short window in which we're dealing with some elevations in temperature. And I'm not disputing that fact, and those elevations in temperature are creating some reductions in what we call the polar ice caps. There's some of this ice is melting, and they say that the ones that are believers of the global warming cycle say that the level of the oceans is going to rise considerably and put some of our beachfront property in danger. There's one article that I've read that says that a lot of the area of Miami, Florida will be underwater. The streets and so forth will be a foot to 18 inches underwater. I'm not a believer in that. Time will tell. I won't be here to see it, I'm sure. But we've lost some of the ice caps or the frozen areas that are around both the poles in recent years. But I'm a believer that cycle will swing back and those areas will reform. But there again, time will tell. I hope you guys are around to witness those changes, and that rather than it continue to go in a warming cycle, I think that would be a real detriment to all of us. But as a component of the hydrological cycle, evaporation is a key component. And the evaporation from plants is called transpiration. And as we said the other day, transpiration is to a plant just like what we have on our bodies with the evaporation of perspiration. We lose that, and that the transpiration helps to control the temperature of plants. it's a moderating effect. So, and we were just talking about the water vapor. It is held in the air, and when it rises, it is cooled, and quite often then condensation occurs. Sometimes if it's close to the ground, it's called fog. And we have, during certain periods of the year, we have a lot more fog than we do others. Certain areas of the land have a much greater tendency to have fog. I know the mountain cap near us has an awful lot of foggy mornings and foggy evenings that limit the visibility, and it affects plant growth with the amount of fog, because that's moisture laden air. Quite often the humidity is near 100%, 99 to 100%. So.
Over in West Virginia during the summer.
Well, and that's because of changes in elevation and things. And in West Virginia, you've got those elevation changes. You've got up currents that the air moves up. And once it reaches the top, elevations, it cools, and then it condenses and comes down. It creates a cyclic effect. So, but when we were talking about the part of the hydrological cycle, when rainwater falls and hits the ground, it percolates down through the soil in a process called infiltration. Or sometimes that rainwater will run off if it comes down too quickly. Been a lot of problems in California and the western states this summer, because they were extremely dry for the last year, and they've had just an enormous amount of forest fires, which has taken a lot of the plant material and organic matter off of the steep ridges. And then they've been plagued also by heavy rains over certain periods of time this summer. And the combination of those two things has dramatically affected their topography. First, the fires, because of the drought, took the plant material and timber off, and now the rain has created a lot of mudslides. They've had a lot of real issues with that. A lot of houses and so forth have been damaged. So, that's a product of runoff from the rain. We mentioned the term aquifer, but an aquifer is what we refer to as your groundwater. It's the level of natural underground reservoirs that exist. And that varies greatly with differences in topography. And you can determine or you can evaluate how close the aquifers are to the surface of the soil, to the surface of the land, if you look at the depth of wells, how close wells are to the surface of the water, surface of the ground. Tom, at your home, how deep is your well?
It's down there ways, but luckily it's being fed by a spring, so it doesn't have to go as far down. But I honestly can't remember.
Okay.
Mine's like 300 feet, I think.
Luckily, knock on wood, we haven't had to pull our pump in a while. So.
Yeah, well, so one of you said 300 feet?
Yeah.
What about somebody else?
Come on, Flint.
Anybody else know?
Mine's 30 foot down.
Your well is 30 feet?
30.
That's really shallow.
That is.
Is it a punched well or is it a dug well?
Well,
Punch well, okay, that's really shallow.
yeah, like if you remove the cap off of it, you can see the water down there just like glancing down with it.
Okay, Tyler says his is 30 feet. We've got a well at what we call my pack house, where we sort of the farm center is, and it's at about 125 feet. My house is 500 or 600 yards from there, and the well at my house is 400 feet. So, and when we were drilling the well at my house, I had a friend that at that time was asked me if I'd had my well witched before we did dug the well. And I said, no, I hadn't had it done. He said, you want me to go check it? I said, yeah, it'll be fine. So he cut I don't remember whether he used a peach twig or a couple of pieces of wire, but he walked all over the hill around where we were going to build my house.
Calcium rods.
He comes back and said, there's not much water out there. He said, I put a stick where I thought would be the best spot. And it turns out that's where we did determine to punch the well. The well driller told me they hit just a little water at about 125 feet, but we went in another roughly 300 feet in solid rock. And he came to me because, punching the well, you're paying for it by the foot. For every number of feet they go, you charge you so much. And he says, I think it's far enough. He says, I don't see any chance of getting any water any deeper, but he says, you've got, a little water, about a half a gallon a minute at 100 to 125 feet, and you've got 300 foot of storage. He says, that's all the water you'll ever need for a normal home. So that's what we used for the last 30 years. Now about 3/4 of a mile to the southeast of where that 125 foot well is, they punched one and they hit water that they couldn't cap. The water began to come to the top. They couldn't measure it, so that water was running out on the ground. So that's an example of what I'm talking about, the difference in the levels of aquifers as we go on, and differences in the pressures. That last one that I was speaking of, there was enough pressure in that area to force the water all the way to the top of the ground. So, to me, it's a very interesting thing about the water table and the way that the water exists under our ground. How many of you are familiar with the process? I use the term witching. Tyler said divining rods. Have many of you ever used a divining rod or seen anybody do what my old friend said, witch a well to determine where water was? Any of you have any experience with that?
My grandpa witched a well the other day for one of
Okay. Do you believe in that process?
I tried it and I couldn't do it, so I don't know.
Okay. Any of the rest of you have any experience with that?
I have.
You have?
Yes,
You done it? You believe it?
I do.
Tell us what you mean.
I mean, depends on how you do it. Well, or how I did it.
How you did it?
Well, I just had the two rods and was walking around, and eventually they started wigging around.
Okay.
Wait, with the rods in your hands?
Yeah.
Oh yeah, I saw a guy do that.
Uh-huh.
The dude did that for ours. That was so cool.
Or else they'll use a willow branch or something.
I've heard Villa Branch. He used wires and it worked. I believe it. It's magic.
Well, I want you to explain to me how it worked.
It had something to do with gravity in the ground and the water and stuff, right? Like I didn't know exactly how it worked, but he was able to follow our pipelines and see exactly where the water drained out.
Okay.
Really neat. Cool.
Anybody else got experience with it? Here's what several of you guys in there. Anybody else done it or seen it done?
I've seen it done, but oh well.
Okay.
I was like Jasmine, I tried, but I don't know what I'm doing about a great many things. So,
my first experience with it was when we were going to drill that well that out near the pack house. There was an elderly gentleman that had the well drilling outfit, and he cut a peach twig and was walking around out there, and I was I don't know, 6 or 7 years old, smart aleck little kid. And I made apparently some derogatory comment to the old gentleman. And he cut his eyes over at me and made some comment about, you don't believe in this. But he walked around, and the peach twig did turn down. And after he did that, he said, now come here, I'm going to show you this. He gave me the peach twig and had me walk around. It didn't do a thing. And he said, well, I'm going to help you. So he had me hold one side of the peach twig, and he held the other. And as we walked around, that peach twig turned down right where he had had it turned down the first time. And at that point, I began to believe in the process. I have not used peach twigs, but I have used 2 pieces of copper wire or welding rods or something of that type, and gotten it to work. It will work for me. But as for the science or the justification or how and why, I have no explanation. But I'm like you were, Jasmine. I've been able to track a water line that I did not know where it was with 2 pieces of copper wire. So that would be an interesting lab report for somebody that didn't have an opportunity to go on a lab experience. So, but it is a fact that does work, and we use it to locate the proximity of an aquifer or a water resource.
I find it funny how a lot of people nowadays don't believe in stuff like the supernatural, yet we are literally casually discussing using 2 pieces of copper to find groundwater, and we don't know how the world works.
That's right, Tyler. And I've never had an opportunity to try to research the science behind it, and I'm sure there's probably a justification, but right now I don't know what it is.
I'm just saying it's kind of ironic how we consider this casually.
Yeah. Well, that's true. Okay. There is a system that classifies climate, and it combines temperature and moisture conditions, and it's exemplified by the polar regions, which are primarily ice covered. It talks about the area of South America, which is primarily tropical and rainy, as one classification. It talks about the African areas, which are primarily desert or dry areas, and then the area in which we reside is being warm, temperate, and rainy. So those are just different classifications that group areas of the world into light type terrain. Not something that you'll be tested on, but it's just something we'll need to be aware of. One of the terms that we use when we talk about weather data being data on a given day or weekly basis, is the term relative humidity. Now, humidity is the amount of moisture in the air. But when we add the term relative to it, what does that mean?
The humidity in a specifically given area.
No, not so much. Anybody got an idea of what we're talking about with relative humidity?
The percent of humidity that a given parcel of air can hold.
At a given time and a given temperature. Yeah. You're right to a point. You just didn't cover all of it. And the key component when we're talking about relative humidity is temperature. You can have the same amount of moisture in the air at 60 degrees and the same amount of moisture in the air at 80 degrees, and you're going to have distinctly different relative humidities. Moist air will hold more water than cold air. Why?
Moist air will hold more air than cold water.
Moist air will hold more water than cold air. Warm air will hold more than cold air. Why?
It's because the cool air.
Because with warmer air, particles are spread further apart, so they have more space.
Exactly.
Yeah, I was trying to find out.
Yeah, that's exactly what it is. Yeah, and so when we add the term relative humidity to it, it gives us an idea of the comparison. So when we're talking about a 90% humidity on a 50-degree day, as compared to 90% humidity on an 85-degree day, which one is more comfortable?
What percentages?
I just use the comparison 50 versus 80, 85. In other words, that 85-degree day with 90% humidity,
That's going to be.
it's going to be oppressive. It's going to be uncomfortable because the conditions that exist for you personally, if you perspire in a day like that, because the humidity is so high, it's not going to evaporate rapidly from your body. But if that humidity had been 60% in an 85-degree day, it's going to evaporate much more quickly, and you won't feel quite as hot. You won't be quite as oppressive. Okay? But when we're talking about relative humidity, it's expressed as the actual water content relative to the maximum amount that air will hold at a given temperature. Okay? Now, that is a thing that we need to be aware of. The next term that we need to talk about is the dew point. So, what's the dew point?
Wasn't that where, like, when the temperature, no, the atmosphere or something reaches like 100% humidity? Something like that? Didn't we say this last week?
You're right. You're right.
Where?
The dew point is the point at which the relative humidity reaches 100%. And it's also the point that you will begin to get condensation on the grass and the leaves and the windshield of your vehicle if you reach the dew point. You get condensation, right.
I have a question.
So, please?
How come, like, when it reaches that point, the front of my car may have, condensation on it on the windshield, but the back of my car does not? Like, only one side.
All right. Share with me a little bit about where your car is located.
Boynton?
Where is it parked?
In the backyard?
Is part of it in the shade under a tree?
No.
Is part of it pointing west and the other point and
I don't know
east?
which direction it's pointing, but I mean, it's parked here, and then there's a camper next to it, and a shed in front of it, and then another. It's kind of like there's a bunch of stuff surrounding it, but all around the side. But it's
Okay, all right, the part that's most exposed, is that the part that's getting the condensation?
the part that's most exposed is the dry spot.
Okay, that's what I was getting at. Okay. It's protected. It's a little bit like what we were talking about with temperature in the city. The temperature is higher because you've got these warm bodies around it. And because of that fact, that temperature in that area was somewhat protected, and it didn't drop as much as it did on the front side, on the side that got the condensation.
And part of it's going to be like the density of the air on the top side of the car versus the underside of the car. There's maybe a difference in the temperature. You know, air can't get into the inside your trunk to cool off the bottom of the trunk lid as much. Where it can get in a little bit better into your cab, but air's got more access to the underside of the hood. So you've got the metals in the three areas actually is going to be at a different temperature, so it will be responding a little differently to the humidity.
You've got microclimate. Okay?
Yes, see?
What's
that?
Yes. Go. I'm remembering things.
If enough people in a room, the temperature will actually start to rise.
Sure, that's body heat. Does that help a little bit? You know, just trying to defend it. Okay, as we talk about dew point, have any of you noticed over the last number of years, if you watch the weather, and I'm sort of a weather geek, I enjoy watching weather forecasts and seeing what's going on with those. But sometimes the weather forecasters will say that we're talking about, say in the springtime, for example, we're talking about the minimum temperatures for an evening, and they'll say that they're going to, low temperature for the night is going to be 40 degrees. And they'll say the dew point is also 40 degrees. The dew point is the temperature at which your relative humidity reaches 100%, and that's also in a still environmental condition. That's going to be the low point in the temperature for that evening. And now, you know, in the spring, if have agricultural interests, say for example strawberries. A lot of folks are growing strawberries on black plastic, and they kind of force them to be out early. Their concern is frost. So they're concerned about what that low temperature is going to be. And if the weather forecasters tell them that low temperature is going to be 36 tonight, and that 36 degree temperature, as we've talked about before, is taken at 5 feet above the ground, that the low temperature at ground level is probably going to be 30 to 31, which will mean there'll be frost to form, you know, in the wee hours of the morning. So they're concerned about protecting their crops. So, you know, they're constantly watching that humidity level and relative humidity and the temperature to determine whether or not they're going to have to initiate frost protection measures. So that's a concern to them. But the dew point is a temperature at which the relative humidity reaches 100%. There's been a lot of work researchers have done evaluating evaporation and transpiration, and it's a key component in what crops are grown, where crops are grown, and how they're grown. There's, in our area, there are a lot of folks that will grow cabbage. Cabbage has been a major crop in Patrick County, Henry Carroll County for a number of years, and the guys have determined that they can grow an early spring crop below the mountain, in other words, at a 12 to 1400 foot elevation. Then they'll grow a fall crop on the mountain because of the temperature that cabbage likes. They're harvesting cabbage right now in the Patrick and Carroll County area that's suited to that type of climate. And then they'll come back below the mountain and grow another late crop. So they're able to do that because of the variations in the topography and in the soil. They have to manage the water to do that, but they learn to do that.
Where is that at?
That's in Patrick and Carroll County. At one time, there was about 3,000 to 4,000 acres of cabbage grown in Carroll County.
Yeah, we got my family has a big farm in Carroll County.
Did they? Okay. What part of the county?
Right there in Dougsburg, near Hillsville.
Okay. Okay. You grow cabbage?
No, it's all planted pines.
Okay.
Harvested back in like they cut the hardwoods in like the 50s and planted it back in pines.
Well, that pine's, they probably thinned it and harvested it one time, haven't they?
Yeah. Well, I don't think they're ever going to harvest them. Their trees are old now, but I don't think they're ever going to harvest them. They kind of just plant them back to harvest them, and then they just left them. They didn't even worry about it.
That'd be a blessing to be in condition to do that. But most of the time when they do that, they'll harvest the hardwood, they'll come back with planted pines, and they'll plant them real thick. And they'll wait about 12 to 15 years and thin them and harvest that basically pulpwood at that time, and then they'll come back in another 10 or 15 and harvest the soft timber. So that's a mechanism of managing forest lands. But you know exactly where I'm. Do you travel up there much? Are you from that area?
Do what?
Do you travel up there much, or are you from that area? You reside?
Yeah, we go there a few times a year. Me and him, we usually go up there and hunt every year.
That's what I figured. Hunting the pine trees?
No, it's well, half of it's pines, the rest of it's just cow pasture. But
Okay.
it's the big mountains, the whole side of the mountains. But green.
You have much left?
Oh yeah, it's pilot. You don't even have to try it there. There's deer everywhere.
Yes, I helped build a house out there, and we did an interesting amount of hunting on the job.
Yeah.
Anyway, that's scary.
Well, right now there's quite a bear population in that area.
Yes, saw those out there too.
Yeah. Yeah, I get pumpkins and cabbage from a family that's just south of there, and one of the sons had an acreage of sweet corn, and we were talking about it Sunday when I was up there. I asked him if they'd seen the bear, and he went to using all sorts of four-letter language that he found that the bear had been in his late sweet corn crop and destroyed about a third of it. He was not happy because of the bear walling around in his corn. So.
Applied pesticide via 30-06.
Do what?
I said applied pesticide via 30-06.
Well, it's Tyler's saying the proper pesticide would be a 30-06. That's fine as long as you have visual on him, but they hadn't seen him. They know he's there, but they haven't seen him. So, as we talk about moisture availability, we have gotten to the point with our agricultural production that we're not comfortable relying on Mother Nature for moisture. In most successful farming operations of horticultural or some agronomic crops and some vegetable crops, there's a consideration for some sort of supplemental moisture. By that I'm talking about irrigation. Irrigation is a complex field. It depends totally upon the topography that you're dealing with, the soil type, the availability of water. Some people cannot irrigate because they don't have water to use. Some of it, water is readily available, and they use big guns and create a lot of big rainstorm in essence with their applications of the water. Some people use center pivot irrigation. Not much of that done in our area. We've had a past student whose family has a large dairy farm, and they've got a center pivot irrigation system on a 100-acre field that they grow corn silage for the dairy cows. But that's the only center pivot irrigation system that I know in our area. But a lot of irrigation is done. Used to be done quite extensively for tobacco in our area. They'll use sprinkler type systems. Some irrigation is done with black plastic and T-tape and trickle type systems. There's an assortment of ways to do irrigation. But it's something that that good agricultural producers don't want to take the chance on, because Mother Nature will usually take advantage of you in those types of deals. So there are some crops that now, if you are going to have crop insurance on, they're going to require that you have some mechanism to water because they don't want to take that liability. So it's an interesting thing when we go to talking about moisture availability. A lot of landscapes are set up with different types of irrigation system because there's a lot of money, time, and effort gone into the establishment of landscapes around homes, different industrial buildings, golf courses. Golf courses have to have different types of irrigation. So, all right, we're about to run out of time again. So we'll just looking. We're about halfway through this chapter, so we'll pick up and talk about C4 plants and their use of moisture when we get back together on Thursday. Thank you, guys. Have a good day.
Okay, y'all drive safe. Oh, and John, for the record, I checked the weather and they're calling for